Okay, now that we've taken a look at the implementation plan for part one, let's go ahead and get started with the whole coding phase. Now with the coding phase, of course, we need to start out by getting some assets set up, the project set up, etc. So let's go ahead, Logan, and begin by doing File and a new project. Let's make an XNA Windows game.
All right, so it begins. Let's make a new XNA Windows game, and let's name this project Precision.
Never thought the day would get here. Okay, so there
here
it
we
is.
go. The Precision project. Now, there's a few things I want to set up. I want to do a little bit of organization on the solution itself, so I'm going to add 2 folders. I'm going to add a folder called Classes, and I'm going to add a folder called Textures.
Want to do it with a capital T? Yeah.
And just to get this completely out of the way, since the class stuff is going to lead on to everything that we have to skeleton, I'm going to get the texture assets imported at this point here. So I have all of the texture assets available as PNG files in our working folder. And just as we've done many times in the past, I'll copy these to our projects folder, where we have the newly created Precision, which contains the textures folder. We'll paste all of these, go back to Visual Studio, add them as existing items, where we can select them from content pipeline files. So we'll add them in. Here's all of our textures. Now there is one last thing that I want to put into the textures folder, and that is the font that we'll be using to describe level change screens as well as to draw the HUD.
And as we've mentioned, when using fonts, please make sure that you are familiar with the license of the particular font because, well, a lot of fonts require you to pay.
Right, and specifically here the idea is, in order to use this font, you actually have to use a reproduction of the font file itself.
That's right.
It's not just a piece of text that's used in a graphic. It's an actual, you could say, recreation of the font file itself, in essence.
Now, we are using a freeware font called Xyrod. Logan, you want to go and pull it up and show them what it looks like? Here it is, Xyrod. And you can see that it says visit, and there's a few different places where you can visit. Or you can just go to Google and type in Xyrod font, and boom, it'll come up right away.
Right, but the key here is there's the copyright, and it is listed as freeware.
Yep.
Now, of course, there should be some README file to it as well, but that's the idea, that this is a freeware font, so we should be good in using this font if we wanted to, say, throw this game up for a free download somewhere.
That's right. And it's a nice, techie-looking font, so it'll work perfect for our game.
So just to note that that's available so that I can go back to Visual Studio and add in a sprite font. So I'll do that here. We'll add a new item, a sprite font. And of course we can pull in a font by name if we want by doing something like naming the sprite font Xyrod. So we'll add that in. There's the font Xyrod. And I'm actually going to leave all of its properties as default. Just the size that this font was created at works perfectly for Precision, so I'm going to close that out. I do want to make sure that I build once so that this name is accounted for, just to get away from the possibility of having typed that wrong.
Okay.
So I'll do a build. The build succeeded, so that meant this font could be found and was properly built.
All right, so now that we have all of our assets in place, let me go ahead and point out that the textures, we will be revisiting the textures a little bit later on, including some Photoshop lessons on how to put a lot of these textures together. But right now you see background cell, enemy, level change screen, player, time power up, title screen. You have already seen all of these in the demonstration that we gave you of the game in play, and also the fill 33. This is the 3x3 graphic that we use for basically scaling up to fill a bar, be a life bar or a time bar for the time power up.
Right, and even though it may be some time before we use all of these, I did want to get them imported just so that as we go about implementing things, we don't have to jump back and forth between files.
That's right.
In order to continue adding on. Since I have all the assets available, I'll add them in here, and we can begin using them as we see fit.
You got it. Okay, so with that, let's go ahead and turn our attention over to some classes.
All right, well, let's add the classes that we need. Let's go to Add New Item. I'll add a class. And let's begin with the Actor class. That will be the first class we add. And while we're in here, let me add all the classes before I begin adjusting anything. So we know we're going to have an actor. We're also going to have a player. And the next class will be
an enemy.
The enemy.
The cell.
Alright, so yet another class, and this one is the cell class.
And finally, the bar.
So one last new class. This will be the bar class.
And now we can go ahead and spend a minute and just do some namespace cleanup.
Right, so let me begin at actor, since a few things will follow suit after actor. Now, I want to clean up the namespaces in that we're not going to use anything from the text namespace, so I'm going to wipe that out entirely.
Mm-hmm.
Now, we are going to need some things available in the XNA namespace. We want to get access
Texture
to certain
2D,
types.
Vector 2, yeah.
So a lot of useful stuff we need there. So I'm going to put in a new using clause for Microsoft.xna.framework. We'll have things like Vector 2. And I also want Microsoft.xna.framework.graphics, and that will allow us to have things like Texture 2D. So it has a few things added here. One other thing I want to do is to clean up the namespace for Precision itself. Since we had a folder, a lot of things are thrown under a class's subnamespace, and I wish to remove that since I want all these classes to remain in the same namespace.
That's right.
So a little bit of cleanup there, and that should take care of actor. Now I want to do similar things to the rest of the classes, and before I change focus here, let me copy these two lines, the XNA framework and framework.graphics, because I'm going to add these to all of the other classes. So next we can jump down and address player. Now with player, I'm not only going to take out text, but I'm going to take out collections as well. And I'll erase both of those, paste in the Microsoft namespaces, and clean up the class's subnamespace.
And while we're in here, we can go ahead and say player extends actor.
Right, that would be a good idea before we shift our focus again. Player does indeed extend actor, so let's set that up as well.
Sounds good.
Now, one thing I wanted to point out is you'll note that I erased the using for collections, but I left it in actor. The reason is that actor is going to contain a list. And a list is a collection. So we need to make sure we leave this line for anything that deals with lists, at least if we want to access them directly and not have to use the fully qualified name and all of that.
That's correct.
But
so let's go ahead and jump on over to enemy now.
So moving down to enemy, same thing. We don't need collections or text, so I'll delete those. I should still have the Microsoft XNA namespaces in the clipboard, so I'll paste them. Then we can wipe out the class's subnamespace. And finally, enemy also extends actor. So let's put that into place.
Beautiful.
All right, moving down the line to cell. Cell does not need collections or text, so we'll delete those out and replace them with XNA Framework and Framework.graphics. Fix the namespace and set cell to extend actor. All right, that takes care of all the actor-related classes and leaves only bar. Bar is once again going to have to manage all of the bars, so we'll need a list, and for that reason I'll leave the collections using in place. I will wipe out the text one and replace it with framework and framework.graphics. And then once again we'll take off the class's subnamespace, and bar doesn't extend anything. Bar is, you could say, a root class.
Okay, so let's go ahead and do a real quick build. We'll just do a lot of builds as we work our way through just to make sure that we don't introduce any problems, and if we do, we catch them early on.
Right.
Okay, beautiful.
But, the build has succeeded, so time to move on.
That's right. So, actor class. That's where we're going to put all of our attention for just a minute, and we can go ahead and start out with the fields. And following our implementation plan, first thing we talked about was a public static list of actors.
All right, so we've got public static list of type actor, and it is going to be called actors.
Okay.
So that takes care of our list.
Now, as we said, fields, we're going to need to keep up with a position, a texture, and a tint. So these are going to be a private for the position, and then our texture and our tint are going to be protected so that if we need access to them in any of the extended classes, we have access.
Right. So let's put down the private vector 2 for position. Then the protected texture 2D for texture. And finally the protected color for tint. Now here's the deal with the private versus protected, is here very shortly we'll turn around and make a property, a public property to access position.
Right.
However, texture and tint are not going to be accessible outside of actor, but they may be useful or necessary later on for some descendant of actor, so we're going to leave them as protected.
Okay, so let's go ahead and jump on some properties now. Let's go ahead and set up that position property that you were talking about.
All right, let's make a public vector 2 property called position. And this position is going to have both a get and set accessor. The get accessor will simply return the field. So let's put in a return for this dot position.
Yep.
And then we can turn around to a set. as I was typing in this, I was thinking, or I was trying to decide whether or not to use the template.
Oh,
because
I see.
It's like, I do have the field, but I don't have the field, but I need the thing, so. All right, but anyway, back to the set.
So we're going to set our position now.
So, yeah. We can set our position to be equal to the value coming into this property. And that takes care of the position property.
Okay, now we've got two more. These are calculation properties. We've got an origin and we've got the radius.
All right. And I am going to change my mind. I'm going to use the template.
Okay.
I'll wipe out the variable here in a second. I can use it to find the type, though. So this is going to be a vector 2, since we're talking about origin. I'll call this origin, because we do have...
With a capital O?
I'll get to that in a second.
Oh, okay, you are going to...
See, this is where I'm always torn between using the template and just typing the thing out, because the template has a lot of things turned down, but things don't work because we don't have an origin field, so it's not quite fitting in with what we need.
I see. I hadn't even looked up other than just long enough to see the word origin and not see that it had set up the field for you.
The whole thing that we talked about earlier is that there is no origin field.
That's right.
It's a calculation based off of the texture.
Exactly.
So public vector 2 origin, and does not have a set because it's going to be a read-only to return the centered origin. And what we want to return here is a calculation. As a matter of fact, it is a new vector 2 that we need to create where we take in our texture. So this dot texture dot width divided by 2 by this dot texture dot height also divided by 2.
Perfect.
And that will be the return value. And I don't know, these sometimes look better as multi-line just because it's a rather long line.
Yeah.
All right, so next property.
So radius is going to come in next.
All right, we need a radius, and this just makes a lot of the other calculations more simplistic since we can look at this as a circular object and get a radius. So we'll have a public int, and we'll call this radius. And radius is going to be read-only, so we're going to put in a get accessor where we return this dot texture dot width divided by 2. And that should wrap up radius.
Okay.
And I believe that wraps up the properties.
It does.
So one thing before we move on is, let me put a region around these. So region for properties. Just so that here in a second I can collapse it and we'll have more screen space available. So enough the region. Let me also build, just make sure I haven't induced anything. And all we have are warnings, so everything there is looking good. Position.
Beautiful.
And all that looks good. Oh, okay, I knew something there.
Oh, yeah. I didn't even see that.
That was bugging me for some reason, but I couldn't quite put my finger on it. There we go. Position is now named correctly, and everything builds.
Okay.
There, now I'm happy.
Excellent. All right, so now let's go ahead and focus on that static constructor and go ahead and create our actors list.
All right, so very quickly, let's throw down a static constructor. So static actor, where we create the actors list. So actors equals new list of actor, and simple as that.
Okay, and now let's go ahead and get the public constructor set up that's going to take in a texture 2D so that we can then assign our texture with it.
All right, so we've got a public constructor. So public actor takes in a texture 2D, which we can call texture. And then since we know what we want to do with this, again, just simply assign it. I know we weren't getting into much functionality, but let's assign this here. Just initialize the texture field. So
there you go.
This dot texture equals the texture parameter.
Perfect. All right, so now that we have that in place, of course, that's going to cause a little bit of grief with player-enemy cells. In fact, let's go ahead and build. And they all just broke. So we could go ahead and take just a second, and let's get all of those errors out. So let's keep this as error-free as we can.
All right, let's create constructors for each player, enemy, and cell so that they satisfy the base constructor.
That's right.
So this can be done by, first, let's address player. So let's put in a public constructor for player where we take in a texture 2D so that we have something to pass to the base constructor. So we're taking a texture 2D called texture.
And then then call the base and send it to base.
Texture. So we have the texture to feed along, and I'll just bracket out the brackets at the side. We may or may not use these in certain classes, but I'll leave them at the side for now.
Sure.
So if I build, that has taken care of player, and we have only 2 errors remaining. So I could probably get sneaky and steal this line and just change a little bit of it.
Mm-hmm.
So jumping over to enemy, we could paste in the constructor, but of course it needs to be named properly. So this is public enemy, and that takes us down to 1 error. And one last paste of the constructor. This is the public constructor for cell, and that takes care of all the errors, and we're back to just a simple warning.
There you go. Okay, so continuing along, that means back over in Actor, we can now move past the constructors into the methods, and let's go ahead and start by setting up our virtual update.
All right, so this is going to be a public method. It's going to be a public virtual void, and it will be called update. Now, update needs to take in
the game time. That's right.
So
Very
we'll
important.
take in a game time parameter called game time. All right, next method.
Next one is going to be our draw actors.
Okay, so we've got a public void. As a matter of fact, if this is draw actors, it's a public static void draw actors. And it's going to need to take in a sprite batch. Since, of course, the sprite batch is created way back in game, but we need to pass that along so that actual drawing can take place inside of Actor. And next...
Then we'll have the draw, so this will be the instance method that we'll call it actually draw.
So this will be public void draw. And again, we take in a sprite batch, which I will call sprite batch.
Okay. And now we've got another static one to put in there, which is going to be a static method for check collision between actor A and actor B.
All right, this will be a public static Boolean now, because we want to return a true or false.
That's
where true
right.
represents a collision and false represents no collision.
That's right.
So public static bool check collision, and we're going to take in 2 actors to use in the check. This will be an actor called actor A, and another actor called actor B. Now this does have a return type, so let me put in a temporary return here. So I'll return false so that we can build and have this actually work.
Okay, and we've got one more method to put in there, which is going to be the check collision with any, and this will be an instance method.
All right, so this is going to be public bool check collision with any. And again, this is going to return false for the time being, just so that I can build the solution without putting a real implementation in place.
According to our implementation plan for part 1, that is everything for actor. So let's go ahead and build and make sure it builds good and nice. Now let's go ahead and shift our attention on over to player now. All right, so player, let's go ahead and add its only field in, which is a private float for invincibility time.
All right, so we've got a private float called invincibility time. So invincibility time.
Perfect.
And let's see what's next. So we
and
need a
we've
property.
got some properties.
So this is going to be a public property. We're going to make a public Boolean for is invincible. Is invincible.
There you go.
So public bool is invincible. We'll have a simple get accessor, which is going to return. And just to finish off the property, I'll put in, I know we weren't getting into implementation, but we've already talked about how this is going to work. And is invincible is true when there is time remaining in invincibility time. So we could do something like return invincibility time, invincibility time greater than 0f.
Okay.
And
simple expression that'll evaluate true or false.
So basically, yes, if the invincibility time is greater than 0, the player is still currently invincible, and this should be true. Otherwise, if this drops below, if it drops below 1, if it's 0 or anything else, then this becomes false, and it's no longer invincible. So, moving on.
So now let's go ahead and set up our method. So we can go ahead and start out with our override update.
Alright, so let's put in a public override, and I'll pick up on IntelliSense here because it has noted that update would fit this. So I'll drop in our update. So public override void update has filled in game time, and I'll leave the call to base.update.
Okay. And now we can go ahead and set up the reset, which is going to take in the float invincibility time.
Right. So we'll have a public void reset method, which is going to take in a float for invincibility time. And since that was so much fun to type last time, I'm going to copy and paste the name. And there we go.
Okay, fantastic. So that wraps up the player class. Let's go ahead and build. And excellent. All right, now let's go ahead and shift our attention on over to the enemy class. And starting out with fields, first thing we've got is a constant that we need to create. So this is going to be our float enemy scale time, and we can go ahead and set it to half a second.
All right, so let's put in a constant of type float called enemy scale time, and set that to 0.5f for half a second.
Okay. Now let's go ahead and set up the base speed and speed variation that we talked about in the implementation plan. And of course, these are going to be private.
Okay, so I'll have private. They're both going to be of type float. First is called base speed. Second will be a private float called
speed variation.
Speed variation.
Perfect. All right, now let's go ahead and get the fields necessary in place for our little moving system. So we'll start out with a private vector2 for point A and point B.
All right, so let's put down some private vector2 for point A and point B.
Okay. Next is going to be a private float for amount, which is the percentage between point A and B when we begin moving.
All right, so private float amount.
And then finally, our move time, which again is a private float.
So again, a private float called move time.
Fantastic. All right, so with that, we can put fields behind us and move on to the constructor. Now, we have a constructor in place, but we need to go ahead and take in the base time and the speed variation.
Right, so let me extend the parameters. We still want texture because we have to feed that to the base.
That's right.
But we also want to take in a float for base speed and another float for speed variation.
That's right. Did I say base time a second ago?
I'm not sure. I was too busy tripping over variation.
Well, in case I did, I apologize. And if I didn't, then my head's wondering right now. Not good.
All right, so first, the float for base speed, and then another parameter, another float for
speed variation.
Variation.
Perfect.
Variation. Also, let me drop the brackets down since I know I want to fill them, because we have two things that we could fill right off the bat.
Mm-hmm.
These represent fields, so we could initialize those fields here, where this dot base speed equals the base speed parameter, and this dot speed variation equals speed variation parameter.
Perfect. Okay, time to move into methods. So the first method is going to be a private one, which is going to be our set random move method.
All right.
Actually, let's start out with the override. I can keep the overrides up at the top.
Okay.
Let's go ahead and start out with our public override update.
The public override void update.
Okay.
And I'll leave everything as is.
All right, now let's go ahead and put in place that private set random move.
All right, so private void set random move. All right.
All right, so now that we have that, I think we have one left, and that is the static method of add enemies.
All right, I'm going to make this public because the idea is that anything outside of enemy can call upon this to make enemies. So this will be a public static void add enemies. Now we're going to take in a few things. We're going to begin with the most important, and that is the integer for num enemies. So how many enemies to create. Now we need another series of things to satisfy the constructor. And what are we looking at there? Texture 2D for texture, base speed, speed variation. Looks all very interesting. So I'm going to copy the whole thing and add this on to the add enemies method. So I'll paste those in place, end off the line, and there we go. Let me drop down, put in our braces, and there we go. All
right, and that concludes the enemy class. Let's go ahead and build and make sure everything's happy, and it is. So now let's go ahead and shift over to the cell class.
All right, moving
in
over
the
to
cell class, first thing we're going to do is create our enum for the cell state.
Oh, here we go. All jumping into the cell. All right, before we jump into the cell, we need that enum. This is going to be the cell state enum. So here we go with enum cell state. First cell state is going to be healthy.
Up, almost.
And yay for spelling.
There we go.
So we've got healthy. We also have attacked. We have saved. And we have dead. Those
Okay.
are all valid cell states.
Perfect. Now let's go ahead and define our fields, starting out with our two constants. First one being the float for cell save time. So after we save a cell, how long will it take for that cell to scale off the screen, or scale down to 0, basically. And we can go ahead and set it up to 0.5f.
All right.
All right, and the next constant being an int called cell placement retry count.
All right, so integer.
And again, this is how many times we will retry placing a cell on the screen so that we're not overlapping with any other cells before we give up, and we will start it out at 100. All right, so now on to regular fields, starting out, well, not quite so regular to begin with, starting out with a static private field that is going to hold our cell count.
All right, so put down a private static int for cell count.
Okay, and then let's go ahead and establish a private variable that will hold the cell state, and we'll call it state.
All right, so this is going to be a private variable of type cell state, and it's simply going to be called state. It's the state of the cell.
All right, now some more normal, if you will, type fields. Let's go ahead and create two private color variables, one called healthy color and one called dead color.
So private color, healthy color, and another private color for dead color.
Okay, now let's deal with the death of a cell. Let's go ahead and create the two private floats for life percent and death rate.
All right, so these are both going to be private. They're both going to be floats. The first is life percent. Second, again, a private float. This one is death rate.
Okay, so that's pretty much it for our fields. Let's go ahead and shift over to properties. So we've got a public cell state property, which will be read-only, pulling out our current cell state.
All right, so let's drop that in. Let's get a public cell state property called state. That is going to be read-only, so only containing a get accessor. That get accessor will return the current cell state. So this dot state. All right, next property.
Okay, next property is going to be the cell count, again, read only. So, and this is actually a static as well because we've established the field is static.
So yeah, cell count is static. So if we try to access this from an instance property, we'll get all kinds of fun errors. Or maybe we won't. Yeah,
you should be able to read it just fine.
Actually, yeah, you probably could. I want to make it static anyway, though.
But the answer is yes, you can. So by making it a static, we'll just simply say cell dot.
I was trying to work out in my head which way that would go. It's like, wait, no, static accessing instance will break. But
yeah.
All the same, I'm going to make this one static. Public static. It's going to be of type integer. I'm going to call it cell count. And it is simply going to access or return the cell count variable.
Perfect.
And I guess we could throw down a region just to follow practice.
Sure.
A region for properties. That way we can collapse it when we're done here.
And ends just a little odd.
And spell just a little bit differently, actually. All right, I'm going to build here because I want to collapse the region. So we'll build and make sure that all we have are variable usage warnings, field usage warnings. So there we can collapse the properties.
Okay, fantastic. All right, so now we've got our properties out of the way. Let's go ahead and move over to the constructor because now the constructor needs to be extended just a little bit to take in a healthy color and a dead color. All
right, so let's add on to this constructor. We want a color parameter for healthy color and another color parameter for dead color. And same as before, let me drop these brackets down since I can, at the very least, initialize their relevant fields.
That's right.
So this dot healthy color equals healthy color. This dot dead color equals dead color.
Okay, so now with the construct out of the way, let's get down to the methods. So let's go ahead and start out with the override update once again.
Public override void has found update. We'll drop all that in and we can continue.
Perfect. All right, so let's go ahead and start with set attacked.
Okay, this is going to be a public method. Void called set attacked. Set attacked needs to take in a death rate. So I'll give a float death rate. Alright.
Okay, now let's go ahead and set up save.
This will be public void save.
Okay, let's go ahead and set up the, let's go ahead and do lerp next.
Alright. So here we go. The public, this will return a color, and we'll simply call the method lerp. I didn't, there we go. I didn't name this any more specifically. I could have named it something like color lerp, but then that would be redundant because we have a method returning a color called lerp, so one can imply that we're linearly interpolating a color.
Right.
Now we do need to take in a few things here, because we want to interpolate between two different colors. So I'm going to give a color 1 and a color 2. We interpolate based on a given amount, so that will be 3 actual parameters we need to take in. So we'll have a color called color 1, we'll have another color called color 2, and we'll have a float to represent the amount. Now since this has a return type, I'm going to put in a temporary return here, and I'm actually going to return the color red. Since red is not a color that cells are supposed to be, that means if we get to the point of trying to use a cell and we haven't implemented this, it'll be very obvious because we'll see the bright red color and know to hunt that down.
Okay, final thing, let's go ahead and create that static method for adding cells.
Alright, this will be a public method. It will be static, and it will be called add cells, much like add enemies. And then we'll take in the integer for the number of cells to create, and then the remaining parameters here are just to satisfy the constructor. What is the constructor here? Well, it contains a texture 2D, a healthy color, and a dead color, all of which can be conveniently copied and pasted after num cells. So finish that off, jump down, and bracket the method in.
Okay.
And it looks like I'm missing a return type, so let's put that in as well. Public static void add cells.
Perfect. And that's everything that we needed for the cell class. So let's go ahead and build. And build succeeded. Very nice. So now we're finally done with the actor class and all of its descendants. Let's go ahead and move over to the bar class and get its skeletoned in.
Alright, so moving over to bar.
So first thing we're going to do is an enum for the bar alignment.
Alright, so let me jump above the class for a second. Let's make an enum and some spelling, and there we go. So enum, this will be the bar alignment enum. So bar, so bar, and let me also do some capitalization. There we go, bar alignment. Alright, what things do we want to have? We want to have left, center, and right, but I want to assign specific values to these. I want left to be holding a value of 0. I want center to be holding a value of 1. And right to hold a value of 3.
Okay.
Now, I'll explain these in more detail when we get on to drawing the bar and how these are going to affect the draw method itself. Right. But the idea is on the outside we have a convenient word, and on the inside we have a value that is meaningful.
Okay. So now let's go ahead and start adding our fields into the bar class. So we'll start out with position. So these are all private.
Okay. So first private.
Private vector 2 position.
Private vector 2 position.
And the next one is going to be a private bar alignment called alignment.
So private bar alignment called alignment.
Now let's go and do our 2 private ints for width and height.
So private, and getting a little lazy with typing, but didn't work. Private int,
yeah.
Width, not capital, lowercase, width. That was so much fun to type, I'm going to copy and paste it.
Okay, fair enough.
To height.
All right.
So there's our width and height.
A private color called color.
Private color for the color field.
And a private float for percent.
Private float percent.
All right, very nice. So now we've got two static public fields to create. We've got the static texture 2D, or the static texture, and the static list of bars that we need to put in place.
All right, so let's put in a static. I'm actually going to make this public.
Yeah.
I'll make a public static texture 2D for texture, and then a public static
list
of type
bar
called bars.
All right. So now let's go ahead and define all of our properties, which we can just get one in place and then just do a bunch of copy pasting.
Sure.
So we'll start out with the public vector2 position.
Public vector2 position. We'll have both a get and a set accessors here, where the get accessor simply returns the field. So return this dot position, and the set accessor sets this dot position equal to the given value.
Okay.
All right. I'm going to build real quickly, make sure there's no simple errors.
Yeah.
That way, when I go to copy this, we'll have everything assured. So I'll jump down a line. Then I'll grab this entire property, copy it so I can paste it a few times. So I paste it in once for bar alignment, once for width, once for height,
and
once
percent.
for percent.
Okay.
Now jumping down back up to the top. Now this isn't confusing at all to have a whole bunch of position things one after each other.
So now let's go ahead and focus on the bar alignment.
All right. So the next property will be of type bar alignment.
And called alignment.
And we need to access the alignment field. And to save on a little bit of typing, I'm going to copy the field name in question, alignment, and paste it over the value that is accessed.
Okay.
All right, next position.
Width and height. So width is the next one. Int.
All right, width, we'll have a type of int. It will be called width, and we'll access this dot width and this dot width. All right, next should be height, I believe. So that will be, again, of type integer. It will be called height and access the field called height.
And finally, we have percent.
All right, this will be of type float. We'll call this percent, where we access the percent field. All right.
All right, very good. So now that we've got all of the properties out of the way, let's build real quick, make sure everybody's happy. Looks good. Let's go ahead and do the static constructor for the bars class, or the bar class, so that we can create the bars list.
All right. So, again, much like an actor, static bar, static constructor, where we create the bars list. So bars equals a new list of bar, and simple as that. Now, before I go too much further, I do want to add in a region around these properties, since there's so many of them. So, let's see, we'll put in a region called properties. Scroll down to about here and end the region. Alright, that allows me to do this, and now we can continue.
Okay, so now that we've got the static constructor in place, let's go ahead and do the public constructor per our implementation plan, where we're going to take in the width, the height, and color.
Alright, so public bar takes in an integer for width, another integer for height, and a color for color.
Okay. Now we've got a couple of methods. We've got our draw bars and draw.
Alright. We've got a public. Let's see, if we're starting with draw bars, that's again going to be static because that means all of them. So public static draw bars, where we will take in a sprite batch to perform the actual drawing.
And then the instance method.
Actually, I think I'm missing a return type.
Yep,
so public static void. And now on to draw. Public void draw, where we take in, once again, a sprite batch, which I will call sprite batch. Throw in some brackets, and that should take care of it.
And that gives us the entire skeleton foundation for precision as per our implementation plan for this part. So let's go ahead and build and make sure everything builds, And it does. It's nothing but warnings, a bunch of fields that are never assigned. No big deal. And that's pretty much it. Huh? It's a good start, Logan. Precision is on its way. So is there anything else you want to add to this?
To look over one of the constructors, I was curious about something, because there's a point at which I need to add something. But let's see. Maybe just a quick thing to throw in, because there's no point where it'll be as clean as this, where we both have actor and bar side by side.
Right.
That is, we have this list, the static list we were talking about, to store all actors on
add
creation,
it into the list?
Or otherwise, I'm sure it's going to get forgotten when we try to actually start running
Probably
this.
so.
So this will be done in both actor and bar. We'll begin with actor, where I'll go into the actor's public constructor. So just after we're creating or have created an actor, we take that actor and put it into the actor's list. So that is actors.add this. That way, any time an actor is created, it gets automatically added to the list, so we don't have to have any type of external cleanup code.
Yeah, and we can do the exact same thing over in bar.
So back up to bars, public constructor, where we have bars.add, taking in this.
Perfect.
So we'll build, everything is still happy, and so that, I think, should wrap up the execution of the skeleton phase.
Okay, so that finishes this video, and in the next video we will do the implementation plan for part 2. Thanks a lot, guys.